We are going to start. So today we are going to work on unit testing from the scratch with PyTest, which is a framework for Python. So okay, I'm going to create a new folder here. Don't hesitate to ask anything in the chat if you want. Okay, unit testing. Cool, and here we will create a file. Or I'm thinking that we can use this probably. Yeah, that will be a bit too much, I think. Let's gonna start clear. Okay. Fantastic. So the first thing I'm gonna do, like always, main, and here will be your code. So let's define math sum with number 2, and then okay, return so we want to sum, for example, 10 and 5, and we want to and we want to print the result. Okay, let's do another thing. Requested. So I'm going to change this. Refactor F6, and it will work. Okay. Current file. No, I'm going to leave a float. For example, 10.5%. Okay, and as we say that this will be like that. Okay, and then I will have a program that will do as well math percent, and I will say for example 1000 and 10%. Okay. Then I'm going to move this to a method main. Oh, I deleted the clipboard. Now. All right. So from here I will call main. That's it. That's important in order to test. So if we run this, okay. So 10 plus 5 is 15. And then the 10% of 1000 is 100. Okay, I'm gonna pretend I didn't see this. To clarify, I want to return it plus the percentage applied. So if I have 1000 and they request a 10%, I will do 1000 plus the 10% of 1000, which is 100. So I will return 1100. So I see that here the code is not doing what I expected, what I was expecting, because I had a mistake on my implementation, so I'm returning 100, and maybe I did not realize this error. So we are going to create a test. I'm going to create it in here to start, and the unit testing files with PyTest, I will talk about PyTest only, start with test underscore. So now I will name after the same file that I will be testing example. Okay. Oh, and sorry, probably the text is too small, probably. Okay, let me see. Yeah, and this is too headless, but what I'm gonna do? Okay, so we are on the test method. But the first thing we are gonna do is import first unit testing example. With doing this import, we have access to the functions that are on that file. So that's why it's important to have everything in a function and not inside the if underscore underscore name underscore underscore equal underscore main underscore, because otherwise we will not be able to test. We will test the functions, and also we will be running code if it was outside the if when we do the import. So I'm gonna just import that, and then I'm gonna define a function, and again it has to start with test. So I need, and that's very annoying. It's very annoying not being able to see the project in this mode. It's really annoying. So I want to test math%. I can test or not main. I want to test these two functions basically. I'm gonna copy them just for myself. So navigate, view, appearance, presentation mode. All right. So I'm gonna test math sum. Yeah, I'm gonna test math%. Okay. Wait a moment, I'm gonna comment this. I'm gonna start with this. So basically, I know that if I call first unit testing example .mathSum and I pass a number, for example, 10 and 5, I know that this should return 15. So I'm gonna do this assertion, which is basically telling, hey, make sure that this match. And we are gonna run this PyCharm sometimes. Exit presentation mode. Okay, so I'm gonna run this test. No module. Oh, okay. So I don't have pytest installed in here, so that's first thing I have to do. So I have this virtual environment, and I have to install pytest. Okay, yes, install package. All right, that's done. Let's run it again. Fantastic, so we ran our first test and it worked. Let me see if I can make the font bigger for you. Settings, font, font. So, okay, what if I say 24? That seems okay. Okay. That's what I wanted. Okay, fair enough. Okay, now we are doing something. Okay, let's go for it. So we know that if we zoom 10 and 5, it should give 15. Okay. But what we want if we zoom, for example, -1 and 1, we expect this to return 0. So we are going to add this test. And what we are going to get if we zoom 1.1 and 1. I will say 2.1. To be honest, we never talk about what are the expected outcome when we work with decimals. So let's do this. Okay, it worked as expected. Now let me do something. I'm going to change this in a bit more nice way. So from first unit test example import, I will import asterisk. So now this prefix is no longer needed, as I'm importing directly the function names. Okay, so this works. And what will happen if I do with this 0, 1? I should have like, or like this. I should have like 1.1.1.1. Let's try it. Okay, perfect. So floats sometimes are more complicated. We can run as well with code coverage. Okay, I'm gonna install the coverage. That option is only available for PyCharm Professional. Okay, install. Let me see if this works now. Fantastic. So what this allows me is to see what's the code coverage from the code. So what code has been covered. So in this case, this has been covered, but this part, for example, main no. Sorry, math sum has been covered, but the math percent not. The comments appear as and the definition appears as covered, but doesn't. So I'm going to add comments here as well. Integers or floats. Let me check if I got a message. Okay, cool. So for me that's okay. The only thing, I will replace this and I will name refactor as f for float, because can be a float, so I don't want like to say I for integer. So with those prefixes I express what's the intention of this variable. So okay, float can be an integer number or a float. Okay, and here return float. The result, and this is the result. Okay, so one to 100 or whatever in the form 1.1 or 1.0, or why not 0 or 0.1 or 10 or 20.5, for example. Okay, so I'm gonna test this function. So I told that, and that's funny. Sorry. And I'm gonna test this function now. So if I do mat% from 1000 and I request 10, I should get 1100. So I'm gonna start by writing the test. I know it will fail because I know I implemented wrongly, but I'm gonna set what is the expected result that I want, and we are gonna run this now. Okay, then I get my test as failing, and it says that it's returning 100. Okay, 100.0. So I'm gonna fix this, and I'm gonna say, okay, I'm gonna to make it more clear, I will do like this. I said I want to return the number plus the number by the percentage, and I want to return the result. And I put this I underscore because I want this to be an integer value. So this is something that was never clarified, but you will see that as we are dividing, and this will be a float, we will get a float in here. So that's not exactly correct, but let's go for it. Okay, I'm gonna run the test. So it is working, but if we print this, we will see that what we get is a bit different. we will get this, which is not what we want. If we run this program, this result may not be the ideal, especially if we do something with a number that is not so pure like 1000 or not so exact. For example, if we do this with, and we request a 10.1%, so the 10.1% of, you will see that this will not look pretty. Yeah, so I get 1223.211. So maybe I don't want to have the result, or we can have even, let me see if I can get something a bit more like horrendous when printing. Not nice to see. Yeah, well, if I keep trying, I will get something like, is not that nice. Okay, so to present a number to a person like this is not very nice. So we may decide that what we want is this function to return the results with two decimals, for example. Give it with the percent requested, summed, and with two decimal positions. For example, this will be 0, 0, or will be like that at maximum. So when we compare numbers, this is exactly the same as this, and it's exactly the same as this. But if we compare strings, that's not the case. So it will be a different thing. So what I'm gonna do is, first of all, this will be a float, not an integer. So I'm gonna do a refactor. F, okay. Then we say that we want to have two decimal positions. So I'm gonna round this. Okay, so now if I run the code, we see that we have two decimal positions at max. Okay, let's do one thing first. So you see, for example, in this case, 6563, if we round to do decimal positions, if we round, the normal thing is that this will be increased to .66, and if we cast, it will be only casted to 65, because when we cast, we remove the extra positions. Let's check what's the explanation for round. Round a number to a given precision in decimal digits. The return value is an integer if n digits is omitted or none. Otherwise, the return value has the same type as the number. N digits may be negative. Okay. So I want to make sure that this operation returns .66. If we were a bank, for example, it's important to know exactly what's the outcome. So I want to make sure that this will be 66. So I'm gonna take this. I'm gonna create a special case test case. So I can call this like a simple test case. I can call this rounding decimals. And then, okay, that's what I wanted to keep. So I want to assert that for 1111, the 10.1% is 1214.66. We say that's what I expect. So let's see if it works. Okay, it doesn't work. Well, it doesn't work because let me see why. Assert. This is returning 1223.21. And I am expecting 1214.66. So perfect. This is the kind of error that I wanted. Now I need to know why this happens. So what I'm gonna do is I'm gonna add I'm gonna do it. It doesn't bring much, but I'm gonna put a breakpoint in here, and I'm gonna run the test with debug, which is really handy. So debug pytest. So when debugging, it will stop in here in the breakpoint. To put a breakpoint, you just click with the left button in here, and it has stopped here. Then I'm gonna step into, and okay, we see that we got 1010, and that's 1100. Okay, so we continue. We came here, and this case was the case that we wanted to test, and step over, and this is 1223.21. Okay, and this is and this seems to be right. Okay, so we are gonna perfect. So the test breaks. So what is going on? Let me run this example. So this is clearly not right. Okay. Okay, I see what happened. What happened is that I hard-coded here the values, so that was a bad idea because I did not did properly. Okay, so I was thinking before that I had to do variables for this, which will make sense. So okay, so I'm gonna say base is 1000 and the percent is 10, and I'm gonna do this f%, and then I'm gonna say and I base, and have to convert to a string to join with other strings, so that will be okay. Okay, so as hard coding it's a pain, what I'm gonna do is an array, and I'm gonna do a tuple, and I will put the base and the percent that I want, and I'm gonna do the same for the others. So that was 1111, and it was 10.1, and this is 1111, and it's 9.333, and here it's 1111, so 9.3371. So the important thing is that when I copied and pasted this to show you, I didn't realize that I had a mistake in here. So I mean that everybody makes mistakes. So the most that we protect the code and the most efficient we are in the sense that not hard coding values and using good methodology, the best. So now I'm gonna do a loop over this array of values, and I'm getting in t values in the tuple values the base and the percent. So okay, so I'm gonna move this, and then the base is the first position of the tuple values, and the percent is the second, which is the index 1, and then okay, this is the same. And now I don't have to have those hard-coded values because I print this from the array. So now when I run this, I see that the results that I get are different. So that's what I expected. So let me remove the round to see what I will get if I don't round to 2 positions. Oops. Round. Run. Okay. So this case is right. So I want to test this. I'm gonna do this. And later I will test this as well. So we say this was wrong to the hard-coded. So I want to test that 9.33% of 1111 is 1214.66. So let's test this. And what's the problem? Oh, yeah. The problem is that I didn't apply the round again. So, nice. So the test allows us to automate the catching of bugs. And that's maybe the last line of defense, because maybe sometimes we are tired or we didn't realize. Okay. When we do tests, we want to test many things, not just one. So I want to test also what happened if there was like a 5 in here. It's 5 rounded to the 3 to the next position, so to 4, or it will just do the same as if it was a 4, a 3, a 2, or 1, or a 0, and keep 73. If memory doesn't fail me, it will be rounded to the next position in this case, so it will be .74. But let's make sure, because we want to know for sure how this behaves. So run. Okay, yeah, was as I expected. Fantastic. Perfect. So now we know that this program works, and when we run it, we get only 2 positions because we round it. We may also want to define a function print number pretty, and I may paste a number. Well, that can be a float, and we'll print a number in a pretty format. And by pretty, I will only consider like if there is .0, it will be printed as just 1100. And we say print, okay. I'm gonna return instead of print. Okay, so what we are gonna do is return number pretty. Okay, so what I can do is, well, if this number is equal to itself converted to integer, that means that the number was at .0, otherwise it will be different. So in this case, I will return the inversion of f number. Otherwise, I will return the number as it was. Okay. So I will say float or int, and I will say here if it had .0 at the end. Okay. So now instead of, okay, we have this. I'm gonna comment this from the previous example, and instead of print the result, I'm gonna, and this should be an F for real, and I will say result nice, or even better, I'm gonna return it as a string, because I think it makes more sense to return it as a string. Okay, so I'm gonna return, so in this case what I'm gonna do is that tell that f number is equal to inversion of itself, and I'm gonna return the string of f number always. All right, so f result nice is equal return number pretty of f result, and I'm gonna print the f, and I have a typo. I'm gonna refactor result. Okay, let's run this. So yes, in this case it returns in a nice format. In the other cases it returns as it should. But I have to add a test for this function, because maybe it may be working incorrectly and I didn't realize maybe. So first I'm gonna run this with code coverage, so we will see exactly which parts of the code are not a test. You see, so basically return number pretty. We are not testing also main, but that's okay by the moment, because basically what we want to focus is into test the individual functions. Initially we can test this, but to test this properly we have to test the output of these prints. So the interesting thing is to have small functions that we can test individually, and we can test this as well, main, but the interesting part is to test the functions. Okay, I'm gonna comment this as I'm not using it anymore. All right, so we say that we want to test this, and we are to create the test. Okay. So then we want to assert that for return number pretty, for example, 1000.0, this will be equal to a string which contains the value 1000. There is an error. Where is an error? It's in red. It's in here. It's displaying the error. Oh, I forgot the colon. Okay. So when we run this, okay, it works. One thing that many times I do as well is that is type is this one object. Oh yeah, so that's this is of type string. Let me see if I did, because syntaxes maybe a bit different. I have not done this for a while like this. Okay, so that the return of this is of the type string. Why not? It's a good test. Okay, no. What is type? Takes 1 or 3 arguments. Or is type? Let me check. No. Let me see if it's like this. Yeah, sorry. Yeah, so we check that this is an instance of a string. And okay, we want to add more cases. So I want to assert that when we ask for a return number pretty of this, well, in this case we should have this as well, because we don't have specified any casting or rounding rule there. So we want this test to be checked as well. Fantastic. And we want to add a weird case like, okay, what happens if we test a negative number? We have not. So what will be? I expect this to behave like this. Let's see. Run. Okay. What happens if I do like this? I expect it to be like this. Nice. In a nice way. Fantastic. And finally, what happened if we have something like, okay, 0.0 will be 0, should be, at least is what I expect. Perfect, perfect. Okay, also I want to add some more cases in here. And I will have another test case for this, and I will name it percent decimals. So we are testing the function mat percent. This is the prefix, test underscore, and this is like a kind of explanation of the kind of test that I'm doing. You can also put comments, of course. So I want to make sure that if I have this and this, I will get this. And I want to make sure that this, then I will get 22 in here. And I want to make sure I want to test negative numbers as well, and I will put in the simple case. So 1000 and minus 10, I expect this to be 90. All right, let's run it. Okay, something is not as I expected. What's it? So if I sum 1000.10 with 10.01, that should be, oh, okay, of course. I did a mistake on the test, so that should be 10.11, and that the same. So the thing is that when this first error happened, the second is interrupted, and this did not run. But this will fail. Let it fail. I'm gonna allow it to fail. Exactly. And you see the line 21. Oh, it's well, the assert. Oh, this one. Sorry. 100.21 is different. That let's check. Oh, there are many errors. Sorry. So 900. So the sums. So 1 dot. Here's unit example. Test math percent simple. No, those are okay. I'm tired and I can notice that I'm tired. Okay. So this is failing. 1000 plus minus 10 should be 990, not 1090. Okay, I did a mistake. So that should be 990. That's the error that it's telling here. And even better. So this name is confusing, math percent, because now I was considering this a sum, and no, the math percent what does is like multiplies, so multiplies by the percentage and adds it to the base value. So what I wanted to do was not this. What I wanted to do this. Sum. I wanted to test sum. So this will be 990. Okay, and this will be 1000 plus the minus 10% of 1000, and which will be minus 100, and so that will be 900, or that's what I expect. Yeah, that's what it was telling, 900. Okay, so I was messing here, to be honest. So let's see now what tests are broken. Okay, this one. Yes. Yeah, of course, because I did like if it was a sum. So so if I get Python and I say Python 3, I say, okay, Python 3, tell me 1000 plus 10 per 10.01, how much is it? So this is the real value that I should get, and as we round to 2 decimal positions, what I should expect to have is this. So this is what I'm gonna put in here. Okay, and that should work if my code works. Now, if I do the other case on line 23, and the percentage is 12, sorry, so this is what I should get, and round will ignore this as is less than 5. This is the result I expect. Okay, now things look great. So now we am gonna run the test to make sure that things work. Okay, we only have one test failed for paste. Let's see what's now. So math percent, so 1000.10 per 10.01. Okay, that's okay. The error is so. I said I'm tired. Okay, so this is the same. So what's the problem? It's on line 22, so is this one. Oh, thank you, Chef. Thanks for your comment. So let's take Python again. Okay, so we know 1000.10. Oh, that's my mistake. You see in here. I think it's in here, because that should be a 10, not a 12. I don't know if this is the case that is failing. Oh, I see what happened. So you see that when I calculate the percent, I divide by 100, and when I try to calculate this in Python, I did not divide by 100, but by 100. So I have to recalculate this. So this will be like that, and this should return me the right value. Even if it doesn't look like, we will work on this. This is what I think I should get. So I'm gonna put this. Yeah, that was wrong. Yeah, I had too many digits. And this I'm gonna fix the other test as well. This is, and then we say it divided by 100. And I expect this. Okay. So I'm very tired. I'm gonna run the test again. Okay, so now it works. So especially in situations where you are so tired, like I am now, because I'm working since 7 in the morning, so it has been like 13 hours so far. You may have like to invest a lot of effort to check the output and match. Sometimes it's faster to run the test again. So basically, I had some mistakes as you saw, but unit testing is the last line of defense. So now, if we run the code with coverage, and we go here, you see that all our code, I'm gonna remove the breakpoint, is being tested. I'm gonna put 2 lines in here. The only function that I have not tested is main, which really has few results, has few possibilities to fail. But I'm gonna do a test, and as everything has been tested, what I want to test in this case is the output. So if let me see how I do. So, okay, let's run the program. So I know these values are okay. So I'm gonna test the exact output of this. And why, you will see. Because imagine that it's a program that is expected to return always the same results, and a callec modifies it and breaks something. So okay, I'm gonna test main. So I'm gonna do def test main. Test main function. I'm gonna hide this. And I know what I expect is to have this. Okay, it's easier when we can have classes as well, but I'm covering only with functions now. So I'm gonna create a variable with the expected output. And I'm gonna use this so I can use multi-line. Okay. So now I'm gonna, in order to test what is output, we need to use something which is called a fixture, which provides additional features, and the fixture we want to use is named capsys, which is for capturing the system output. So then I think it's capsys dot standard error. Yeah, so we will capture the standard output and the standard error, and then we want to assert that the output that has been captured from the program is equal to the expected output that we have. And we also want to assert that the standard error contains nothing. So let's test it. Okay, so what's going on? So it's telling that an empty string is not equal, obviously, to this. So why capture.out is an empty string? Obviously, because I have not been called main. So it could not work. So obviously it was returning nothing because I was doing nothing. So let's do it again. Okay, so we can see the difference here. That's a typical error. So I'm comparing this string I'm comparing this string to this string, and if you can see, the /n is the jump of line, the next line. So I added an additional line that the program is not returning, or I will say the opposite. I will say that here, when I run this, I get a jump of line, and makes sense because print does the jump of line. So if I want to test, or I add a jump of line and test that like this, or I add a jump of line in here like this. Whatever I prefer. I prefer to use this, to be honest. But both methods work. Now all the tests have paste. So, and why is useful to test the output? Because it may happen that a callec screws it and doesn't realize and removes a character. Or maybe I have a typo. So I run the program and I don't realize this, or maybe instead of off there was a typo, and it's more difficult to see. But when we run the unit tests, as we know that we expect the right output, it will not work. It's telling, and we can click the difference, that we are expecting this expected of, and that we are returning odd. And you see that it's marking in blue the difference, which is very handy. So if we show this in a like real case, for example, the program I use to copy the test, the Fixture capsys, is named ctop, and I created, and it's a tool that checks all the system information from the information from the system in your Linux. So it returns the IPs from your Docker interfaces, it returns the most repeated process, the percentage of inodes, the free space, memory. Well, it's a tool that I created. The thing is that I could also have mistakes in my program, and in fact, I have some mistakes. For example, these scales, when I make it bigger, these scales, and if there is an odd room, I add extra information, but not everything is tested with unit testing. So we may find a problem, and we will, because it's a documented error. So for example, I know certain things work because I have unit tests. For example, you see those listening ports, as I reduce the screen, the string is truncated, so it doesn't break the string. But there are other things that will not work the same, and you will see that this will collapse. So for example, you see here, the two strings are collapsing, and I should have unit testing to make sure that this situation never happened. And then I should make my code to reduce the number of visible columns when this happens, or when there is not enough room. So unit testing, and you see this line is so long that it jumps to the next line. So you see, when we don't have unit testing, we can have bugs that we don't detect. Or for example, if I had a bug in my function that detects the swap, I may be returning 0.00, but I could have swap in use. And that was an actual bug that I had when I was programming this tool. So it's really necessary to create unit tests in order to have a reliable code and a professional code, and code that you can trust, and it's scientifically tested. I mean, that always will produce the same output. In many cases, the last line of defense between you and an error in the product that you are creating. So it's very interesting to create unit tests, and makes your code more reliable, and also prevents problems, like I said, when working in team, that if somebody makes a typo, then it breaks the project. So ideally, in a company, if they work the way they should, you should not commit anything to master, and ideally not to your branch, but we can discuss about that, but for sure not to master if all the tests have not passed. So in this case, now all the tests passed, so I could be able to commit this exercise. First unit testing exercise. And okay. So if we want to work in a professional way, we have to use this methodology. Okay, so that's today. That's all for today. And next class will be on Thursday, and it will be about programming in unit testing, object-oriented programming, using inheritance. Thanks for coming. Thanks for the comments.